Good morning, everyone. Today is Wednesday, October the 6th. We're on our second day of 3.02 distance formula. You should get your paper or pencil. Yeah, these are wrong. We actually don't need to know the format of a standard form of a circle. We will, though. We will later this week. And same thing for completing the square. Make sure you review completing the square. Go on YouTube and just type in completing the square. Just brush up on it because we're going to need it later this week. Distance formula. Just like yesterday, we had a midpoint formula. Well, we have a distance formula. This should look really familiar from geometry. Formula is b equals the square roots of x sub 2 minus x sub 1 quantities squared plus y sub 2 minus y sub 1 quantities squared. Take note that we are subtracting the x values, squaring them, subtracting the y values, squaring it, but then you have to add them. So make sure you have these written down, the midpoint formula and the distance formula. All right, let's jump on in it. All right, so what should we do first in this problem? Label it is correct. Let's label everything. All right, so we're going to call this x sub 1, y sub 1. And then we're going to call this x sub 2, y sub 2. Yeah, always label your points. All right, so everyone go ahead and set it up. And let's do this. I'm going to give all of you 30 seconds to solve this problem after you set it up. 30 seconds hopefully is enough. Ready, go. All right, what did everyone get for their final answer? We got rad 234, rad 226, more rad 234s. So make sure you simplify your answers. If you gave your answer and it is not simplified, it is not correct. So if you left your answer as a square root of 234, you are not finished with the problem. Everyone in chat. So we have a total of 9 people here. Give me a green check if you're actually listening to me right now, so I know who is actually here. Hopefully everyone. And after you respond, I want you to put which model calculator you are using. If you don't have a calculator and you're using your computer, type in computer as your calculator. Okay. All right. The TI-30X2S. I believe that one, if you type in the square root of 234, does that one simplify your radical for you? Oh, it gives you decimal? So there should be, so when it gives you decimal, there should be a key on your TI that looks kind of like that. I don't have that model, but do you have that key? What about that? Do you have that key, SD? So mine has the SD key. Yeah, I don't know if that's probably fraction decimal. Yeah, it's a fraction of the decimal, I think. When you hit that key, does it put it into radical form for you on that TI model? You should get one. You should beg one of your friends or family members to buy you one. All right. Well, that's too bad. So, guys, in this class, it is possible to do this course with using like a calculator on your phone or your computer. You won't do as good, in my opinion. You really should invest $10 and get the FX 300 from Amazon. I'm not a huge fan of TI models, and the reason why is they seem to be overpriced. So that TI 30X2S model, I don't know, is that 15, 20 bucks? So if you had the FX 300 or the FX 150 and you typed in the square root of 234 and hit enter, that model would actually simplify your radicals for you. It's really nice. A lot nicer than that TI model. I feel like the TIs, they're just overpriced compared to like Casio. You get more for your money with the Casio models. Now, I do like the TI graphing calculators much better than the Casio models, but they're also expensive too. So B says it's helpful for radicals. B, do you have the FX model? Oh, you have the TI-30XS? Okay. Yeah, so different models have kind of different features, and yeah, I really like the FX 300. So guys, if you can't do radicals on your calculator, you need to know how to do them by hand. So let me scroll up and see what you guys got for your answer. I totally missed it. So it's like 3 radical 26. That sounds right. Yeah, 3 radical 26. Yeah. Actually, my answer key, or I typed it wrong, but let me just fix it on my screen. I forgot to fix it before class. Yeah, so whoops, that's a big oops. That should be 3 radical 26. But you should have shown your work like I did here. Sorry about that. My dog's a princess. She wanted me to put the blanket on top of her. Anyway. So let me show you real quick. I'm probably going to only do this one time, but if you should probably maybe look on YouTube on how to simplify radicals, but I'm going to do this one real quick. So 234, when I taught this back in the day, we simplify. So, or we do a factor tree. So we get 2 and what is that? 117, I think. Yeah, 117. And then we do this and we get 3 and 30 what? 30 something. 39? 39. And then we get 3 and 13. So we factor everything, and then for square root we need groups of 2. So I got a pair of 3s. So that comes out in front as a single 3, and then I box everything else that doesn't have a match. So this is how I taught it back in the day. And so the 3 comes out in front, and then 2 times 13 gives us 26. So that's how I taught it, and that's how I do it by hand, if you're wondering, if you had forgotten. But everybody in this class should know how to do it by hand, like I showed here, to get the simplified final solution, or have a calculator that does it for you. Guys, really, you can get away not having a calculator this semester. Next semester, you're really going to need one. And people who are struggling because they don't have one next semester, there's nothing I can really do for you, except do your best on your computer calculator, because we need to be able to switch between radians and degrees, from problem to problem, and it's not that easy on a computer. It's not very intuitive, and a lot of things that you can't do on the computer calculator you can do like on a TI or a Casio model. Yeah. So the thing with those graphing calculators, you need to, whenever you want to think on that model, like you're like, hey, how do I, type in fractions? You should probably go on YouTube and type in your model, and then maybe put like fractions, and watch some kind of tutorial videos on using those graphing calculators, because there's a lot of features that you may not know about that those things can do. But anyway, all right. If you put radical 234 and stop here, your answer is completely wrong. You need to finish the problem by simplifying it. Okay. All right. All right. Everyone, let's look at this one. Okay, let's label stuff. So this one says we have the distance of the segment is 4 rad 34. the coordinates of the endpoints are 7, comma, -2, and -3, comma, k. This wants to know, what is the value of k? So we should do what first? What's our first step? Should label stuff. Yeah, no, don't plug it in. Don't plug it in. We got to label stuff, Isaiah. Yeah, best practices. Let's label stuff. Let's call this x1, y1, x2, y2. What would I call this for rad 34? Yeah, I call that D. Yeah, so let's label everything. Okay, everyone go ahead and plug this stuff into the equation. I'm gonna give you 30 seconds to do that. All right, let's take a look. Did everyone set this up correctly? Did everyone have the parentheses where they belong? It's like one person is not here. Uh-oh. Uh-oh. All right, so everyone they are here. They got it right. Okay, everyone simplify. Everyone simplify what we can. -3 minus 7. And I kind of did a couple things in one, right? -3 minus 7 is -10, and -10 squared gives us 100. You may have showed one more step than I did, and that's probably better to show more work. I just did this in my head and squared and got 100. And then we should all know that two negatives make it a positive. All right, so do some of you want to square this binomial? Do some of you have the urge to do that? I would avoid it. You can, but if you do decide to FOIL this out, we're going to have, if you multiplied this k plus 2 times itself, you would get k squared plus 4k plus 4 as your trinomial when this is FOILed out. And you're making the problem a lot harder than it really is. And you're going to have, and you can do it that way. If you go down that rabbit hole, it's going to lead you into a trinomial that you can't factor unless you do complete the square. So you better know how to do that. And definitely everyone should review that before class, really before class tomorrow. Or we can use the quadratic formula. So, and that's if you do it that way. But there's an easier way to avoid using quadratic formula and to avoid using complete the square by just leaving it alone for now. Okay, what do we do next? Square both sides. All right, everyone go ahead and square the left side, square the right side. Don't put your answers yet, please. I'm gonna give you 30 seconds to do that. Right. And when you finish squaring both sides, give me a green check so I know you are ready. I will wait for everyone. Let me know when everyone is done. Looks like one person is still not here yet. That is too bad. All right, now everyone go ahead and type into chat what you got. Everyone, please give me their answer. What did everyone get for their answer for the left? Sorry, the left part of the equal sign. What did you get for your number? The left side. The left side only. What is the number? We got 136, we got 444. What else we got? We got 544. Okay, so Isabella said she got 544, and then she subtracted the 100 to get 444. Okay. So on this step here, this next step that I'm going to show, all right. So it looks like 1, 2, 3, 4, I don't know, 5 people, 6 people. Some of you who are here didn't put an answer. And you guys, I really want to see what you got. I really want to see what you got. All right. So everyone should have got 544. When you square the left side, you should have got 544. And let's show the work. So we're gonna square this side, and we're gonna square the right side. Well, we all know that squaring a square root just cancels each other out. So nobody should have got the right part incorrect. Okay, so there's the right piece, right? Now, when you square a number, are we just squaring the square root? Yes or no? Are we just squaring the square root? So whenever you square both sides of the equal sign, you cannot pick and choose what you want to square. You either square the entire side or you don't square anything. Yeah, we have to do the whole thing. So whenever you square both sides, you are squaring this entire number. You are not just squaring the radical. This is, remember, this is two factors. This is 4 times radical 34. So you got to think about your power rules. Whenever you square factors, you have to square every factor. You're squaring this 4 and you're squaring this radical. Take note the difference between squaring a binomial. We cannot square the k and we cannot square the 2 separately. It is not the same thing. Squaring factors is not the same thing as squaring a binomial. Squaring means times itself. So we're just doing 4 radical 34 times 4 radical 34. When you square this binomial, you're doing k plus 2 times k plus 2. It's different. And 4 squared is 16, and squaring a square root, they just cancel each other out to just be 34. So like Enzo said in chat, we're going to have 16 times 34 is 544. If you made this mistake, don't make it again. All right. And then I think Isabella said we subtract 100 both sides. She is correct. And then what do we do? We square root both sides. All right, so everyone take the next 30 seconds and square root 444. 30 seconds, ready, go. Okay, when you did the square root of 444, what did you all get? Ooh, Enzo said plus or minus 2 radical 111. Is it plus or minus? Okay, and the lesson it says it, but why? But why, Enzo? Why is it plus or minus, other than you just saw it in the lesson? What's the reason? Okay, so you said because 2 times 2 is the same as negative 2 times negative 2. And yeah, that's true. Right. So you're reasoning through it through a basic example. I get it. So guys, whenever we solve an equation, now, whenever you solve an equation, if you are the one that square roots both sides to solve an equation, it is a rule. If you are the one doing this operation here, do not forget plus or minus. It is a rule. If you square root both sides, do not forget plus or minus. It is a rule. And the square root of 444 is 2 radical 111. Either you typed it in and hit enter and it gave you that simplified radical, or you did it by hand. All right, what's the next step? Minus 2 both sides. Yep. And we generally want to have that minus 2 in front, not after, because generally speaking, about writing answers in proper form, we're going to have we're going to have variables first, then your constant term, and then your term that have radicals in them. So generally speaking, that's the standard form. So that means that we solve for k, so we're going to write our answer twice. K is equal to negative 2 plus 2 rad 111, and k is equal to negative 2 minus 2 rad 111. So we got 2 answers. If you were to go to Desmos and you were to graph all 3 points, you graphed 7 comma negative 2, and then you graphed negative 3 comma the first k value, and then you graphed negative 3 comma the second k value, you would see that these 2 points that we found are the same distance from the original point 7 comma negative 2. Kind of cool. Kind of cool. I don't think this is a TGA problem. After class, I will check to see what the TGA problems look like. I don't remember. All right. Everyone quickly do this problem. I'm going to give you all 2.5 minutes. And while you're doing that, I'll look at the TGA for Unit 3 and see what I see. All right, 2.5 minutes is up. In chat, I put the TGA. You're gonna have 3 problems, of course. First problem is just graphing an ellipse and labeling everything. Numbers 2 and 3 are word problems involving conics. All right, what did everyone get for their final answer? Do I want answers written out with plus or minus or separately? You can put plus or minus. That's fine. Yeah, if you're given answers, plus or minus is good. Either way. So radical 241. I believe 241 is a prime number. So if you're trying to simplify radical 241, it doesn't, it doesn't factor at all. Yeah, it's a prime number. Oh yeah, radical 241. All right, who got that correct? Everyone. Super easy problem, right? That would never be a TGA problem. All right, I got 2 more examples. Yeah, we have time to do both. My 8:30 class, we actually ran out of time. I had to skip this one. So let's do, I'll give you 3 minutes for this one. This one's a little bit longer, maybe. 3 minutes, ready, go. All right. What did everyone get for their K value? Looks like somebody already posted. We have K is 5 plus or minus 2 radical 7. So we got a lot of 5 plus or minus 2 rad 7s. Let me check my answer real quick. Yeah, that looks correct to me. Right, who got those correct? It's like almost got it correct or got it correct. Okay, so let's kind of just quickly look at the work. You should have labeled your points on your paper. We do the math. We square both sides. You subtract 36. Then we square root both sides. Don't forget plus or minus. And the square root of 28 is 2 radical 7. Just looking at people's work in the chat. Yeah, so again, make sure that you simplify your radicals. If you left the answer as -5 plus or minus radical 28, it would be incorrect because you are not done. So don't forget, do not forget. And like I said before, we're going to have the constant, you're going to have you're going to have variable terms, and you're going to have your constant term, and then you're going to have your term involving radicals. That is the standard form. So if you put plus or minus 2 radical 7 plus 5, it's technically not wrong. And if it was on a TGA, I wouldn't mark it wrong. I would circle the 5 and I would draw an arrow to the front. I wouldn't mark it wrong though. I wouldn't, not for that at least. But you should know standard form, it should look like this. All right, our last example. So this problem is difficult only by the pure fact there's fractions. But again, guys, everyone in this class should be able to do fractions fairly well. Whether it takes you a long time or not, that's a different story. But all of you should understand how to deal with fractions. Whether you add them, subtract them, multiply them, divide them, square them, square root them, we should all know how to deal with fractions. And if you don't, you better have a calculator that when you type stuff in, it does it for you. So let me give all of you 3 minutes for this one. I think we have enough time. Oh yeah, we got 15 minutes. So I'll do 3 minutes, and then I'll check to see who's done. And if not everyone's finished, I'll give you more time. Okay, 3 minutes. All right, who's done with this problem? All right, everyone's done. Okay, what did everyone get for their answer? I'm kind of curious. I don't think anybody got this problem right in my 830 class. Well, no, they did. No, they did. Some people got it right. So radical 505 all over 6. Radical 505 over 36. Oh, you haven't. Okay, you haven't simplified yet. All right, I understand what Brady meant to put parentheses around the entire fraction, not just the top. Yeah, that's what Brady meant, Isaiah, when he put his in chat. Well, he said 36, not 6. All right, so Isaiah, you're saying the answer is plus or minus the square root of the entire fraction 505 over 6? No parentheses. All right, so Isaiah, you are incorrect. So let's take a look. This is the final answer. So people who wrote that in chat, which is quite a few of you, did put that answer. Again, who got that correct? We got radical 505 all over 6. All right, so let's figure out. I'm just taking note of the ones that did not get it correct, and let's figure out where mistakes were made. Mistakes were made. All right, so did everyone get the setup correct? Pretty sure I know where the mistake is made. Did everyone simplify correctly? I'm going to assume everyone also did that correct. Whether you typed it in or you did it by hand, all of you should have got that. Okay, good. Yep. Did all of you square the fractions correctly to get that step done? Ooh. So yeah, I believe this might be where a mistake was made. So let's talk about this one. Let me see. All right, whenever you square a fraction, so whenever you square a fraction, we know that squaring a negative makes it positive, right? Whenever you square a fraction, you need to square the top and the bottom. So we're doing 4 squared and 3 squared. 4 squared is 16, 3 squared is 9. 7 squared is 49, 2 squared is 4. All right. Or just typing this in. We could have done parentheses, negative 4 over 3, in parentheses, square, hit enter, you would get 16 over 9. And same thing for this one. Okay, and then all of you, we have 16 over 9 plus 49 over 4. We're going to add these together. Either you know how to do it by hand or you have a calculator that does it for you. Butterfly method. I don't know what that is. But regardless of how you added these together, you add these together, you should get 505 over 36. If you got this step correct, but you didn't get this, going from this to this, you need to review, go on YouTube and type in adding and subtracting fractions and get a refresher on this concept. I'm definitely not going to cover this. This is definitely well below required skills for this class. Oh, I got you. I got you, Brady. It's called the butterfly method. All right. Did not know that. Okay, then as a refresher, whenever you square root a fraction, it is the same thing as square rooting the top and the bottom separately. So again, I'll say that again. Whenever you square root a fraction, it is the exact same thing as square rooting the numerator and denominator separately. So that's what we have to do. We have to separate the square root of the entire fraction into the square roots of the parts, numerator and denominator. The square root of 505, this does not simplify further. The factors of 505 are just 5 and 101. And 101, I believe, is a prime number. So this does not simplify further than what you see here. The square root of 36 is 6. So that is your final answer. You got that far, nice job. If you made a mistake, I really hope that you found where it was and you can avoid that in the future. Right. So, guys, if you stopped right here, I would mark this completely wrong. I mark it wrong all day long. This problem is not finished. You cannot have a square root of a fraction as an answer. You have to simplify it. You have to rationalize the denominator. So let me go on my next page here. Well, actually, I'll talk about it here. So if you still had a radical in your denominator, you would have to rationalize the denominator to clear radicals from your denominator. Remember, whenever you have a final answer, you can never, ever, ever, ever have a radical in the bottom portion of the fraction. Never. Always simplify. If you don't simplify, if you stop here, if you don't simplify, the problem is not done. If the problem is not done, you don't get credit. That is my thinking. When I grade stuff, to me, a lot of things are black and white. It's either it's right or it's wrong. I don't know. Maybe I just can't see the gray area, and I don't. Either you get it right or you get it wrong, and for me, there's no partial credit. That's how I grade. I don't want to reward people for giving wrong answers. You are rewarded with points when the answer is correct. I know not every teacher is that way. I am that way. So yeah. So it's not English, right? You read a paper, it's up to interpretation. One reader might grade you. If it's out of 6, they may give you a 3 out of 6. If another reader might read it and they might grade you as a 4 out of 6. Whereas math, either it's right or it's wrong. There's no interpretation. Yeah, software engineering is good. I was almost a software engineer. Almost. All right, final thoughts. All right, now I said a lot of these already, but just final thoughts, and this applies to the entire math course, not just today's lesson. Number 1, answers need to be simplified, also known as reduced. Number 2, fraction answers should be reduced and kept as proper or improper fractions. If you are unsure what the difference is between the two, you might look it up. But an example of a proper fraction would be something like 2. Oops, that's not my pen. Example of a proper fraction would be like 2/3. An example of a reduced improper fraction would be like 6/5. So, it's improper for the number to be larger on top. Why isn't my pen stopped working? Uh-oh. My touchscreen stopped working. Oh, there it goes. There it goes. All right. Yeah, it's improper for the number to be larger on top. That's called an improper fraction, but it's reduced. Yeah, reduced, improper fraction. Never, number 3, never have mixed fractions. An example of a mixed fraction or a mixed number would be 1 1/2. There is no place in pre-calc for mixed fractions. I've had a couple people in Unit 1 on TGA give me their answer as a mixed number, and I was like, what? I haven't seen it since. So yeah, guys, no mixed fractions in this class. There are places where you would want to use mixed fractions. If you're baking a cake, you need 1.5 cups of flour. Sure. Number 4. Rationalize the denominator. Now, we did not do this today, but if you are hazy on doing this, I would definitely look this concept up on your own time, preferably today before you forget. And the reason why we do this is because we cannot have radicals in our denominator. And number 5, notice how I underline this. Never give me decimal answers unless otherwise stated, or unless there was decimals in the word problem already or in the problem, and then it's acceptable. So the rule is, if the problem does not have decimals in it, you should not give me decimal answers ever. Never give me decimal answers. All right, everyone. Well, thanks for coming. As always, I hope you learned something. I will see you all tomorrow.